Hi guys, Maing Adlaw. Welcome back to my channel. For today's video, I will be presenting to you about finding the asymptotes of a rational function. This is in preparation for the next topic about plotting the graph of a rational function. So, to start, we have here finding the asymptotes of a rational function. Before we proceed, let us have the lesson objectives first. Number 1, at the end of this video, you should be able to find the vertical asymptote, horizontal asymptote, and oblique asymptote of a rational function. Number 2, you should be able to illustrate the asymptotes of a rational function. And number 3, you should be able to find the domain and range of a rational function. This topic requires us to have a prior knowledge on the following skills. Number 1, division of polynomials, and plotting the graph of a linear function. So to start, let's proceed to the definition of a rational function. A rational function is defined by f of x equals the p of x over the q of x, wherein the p of x and the q of x are all polynomials. And see to it that our denominator should not be equal to 0, and that is the q of x. Why? Because this will make the whole function undefined. So take note that the domain of a rational function are all values of x, except the value that will make the q of x equal to 0. And to find the range of a rational function, we simply get the inverse of the given rational function. So to start, how do we find the vertical asymptote? So any value that would make the denominator equal to 0 is the vertical asymptote. And to find the vertical asymptote, we just simply equate the denominator to 0. So meaning, we will just simply focus on the denominator. So denominator should not be equal to 0. So let's start this example. f of x is equal to x plus 2 over x squared plus x minus 6. Our denominator for this function is x squared plus x minus 6. Remember, this is a trinomial and this is factorable. So before we equate this one to 0, we need to factor out this trinomial first, then afterwards we equate to 0. So the factors of x squared plus x minus 6 are x plus 3 times x minus 2 equals 0. So by using the properties of equality, when we equate x plus 3 to 0, this will become x equals negative 3. And for the second factor, x minus 2 equate to 0 by addition property, this becomes x equals 2. So therefore, the vertical asymptote for this specific function is x equals negative 3 and x equals positive 2. And if we are going to illustrate this one in the rectangular coordinate plane, so we will have x equals negative 3. This is from 0, negative 1, negative 2, and negative 3. So this is our first vertical asymptote. And the second vertical asymptote is x equals positive 2. So we have here from 0, positive 1, and positive 2. So therefore, this is our second vertical asymptote. And the domain of this function are the real numbers except the values negative 3 and the positive 2. Again, because these two values are the values that will make the denominator equal to 0. So let's proceed to the second example. For example, we are given g of x is equal to 2 over x squared minus 16. Same, we need to factor out the denominator x squared minus 16 and equate to 0. Since this is the sum and difference of a binomial, so x squared minus 16, the factors of x squared minus 16 are x plus 4 times x minus 4 equals 0. So we equated this one to 0, Therefore, our vertical asymptote for this specific function are -4 and +4. So if we are going to illustrate this one in the Cartesian plane, so we have here -1, -2, -3, and -4, our first vertical asymptote. And our second vertical asymptote would be +4. So this is +1, +2, +3, +4. Again, the domain of this function are real numbers except -4 and +4 because these values will make the denominator 0 for this specific function. Still on finding the vertical asymptote. For example, we are given h of x equals x minus 5 over x plus 3. Our denominator here is x plus 3. So we equate this one to 0. No need for us to factor out because this is not factorable anymore. We just simply equate directly to 0. So that gives us x plus 3 equals 0. Then by using subtraction property, this is x equals -3. So the vertical asymptote is x equals -3. So we only have one vertical asymptote. If we are going to illustrate this one in the number line, so we can find it here. So this is our line for x equals -3. So this is 0, -1, -2, and -3. So the domain of this function are real numbers except the number -3. Let's proceed to the next example. Still on the vertical asymptote. Say you are given p of x equals 2x over 2x minus 3. So our denominator, still on the denominator, 2x minus 3. What we need to do is to equate to 0 and solve for x. So 2x minus 3 is not factorable. So we just simply equate this denominator to 0 directly and afterwards we solve for x. So that becomes 2x minus 3 equals 0. Then, by addition property of equality, that gives us 2x equals 3. Then, afterwards, we divide both sides by 2, so that gives us 2x over 2 equals 3 over 2. Then, common factors in the numerator 2 cancel out 2, so what remains is x equals 3 over 2. So, therefore, the vertical asymptote is x equals 3 over 2. Or in a mixed number, 3 over 2 is equal to 1 and 1/2. So if we are going to illustrate this one in the number line, this is positive 3 over 2. So we have here 1, positive 1, positive 2, positive 3. And since 3 over 2 is 1 and 1/2, so that the line is in between positive 1 and positive 2. So this is your line for x equals 1 and 1/2 or the 3 over 2. So this is how to find the vertical asymptote. By the way, the domain of this function are real numbers except 3 over 2. So to proceed to the horizontal asymptote, so how do we find horizontal asymptote? For horizontal asymptote, we need to remember some cases. So to find the horizontal asymptote, we compare the degrees of the polynomial in the numerator and the degree in the denominator. So case 1. If the degree of the numerator is less than the degree of the denominator, the line y equals 0 is the horizontal asymptote or the line x-axis. So, we compare the degree of the numerator and denominator. Let's have this example. For example, we are given this function f of x equals x squared minus 4x plus 3 over x cubed minus 1. When we compare the degree of the numerator, this is our numerator, and the degree of the denominator, so we have the degree of the numerator is 2. Remember, the degree is the highest exponent in a polynomial. So in this case, our degree is 2. And in the denominator, the degree of the denominator is 3. So we have here x cubed minus 1. So if we are going to compare the degree in the numerator and denominator, that is 2 is less than 3. That satisfies the first case. So meaning, if this is the case, our line y equals 0 is the horizontal asymptote for the x-axis. So if this is our Cartesian plane, our horizontal asymptote is this red broken line. Okay. So again, remember that the degree is the highest power of the polynomials in both the numerator and denominator. Let's proceed to case number 2. Still, again, we compare the degrees of the polynomials in the numerator and denominator. Case number 2. If the degree of the numerator is equal to the degree of the denominator, is time equal to the degree of the denominator, then the quotient of the leading coefficient is the horizontal asymptote. So let us have this example. H of x equals 4x plus 3 over 2x minus 1. So if we are going to compare the degree of the numerator, our degree here is 1. While in the denominator, 2x minus 1, our degree here is also 1. That means the degree in the numerator is 1 and the degree of the denominator is also 1. That means the degree are equal. So what we need to do is just simply find the quotient of the leading coefficient. So what is therefore the leading coefficient of the numerator? So this time, our leading coefficient is 4. When we say leading coefficient, it is the coefficient of the term containing the highest degree. So in this case, we have 4 as our leading coefficient. While in the denominator, our leading coefficient is 2. So when we find the quotient of 4 divided by 2, that gives us 2. So therefore, our horizontal asymptote for this function is found on this line here. So this is our horizontal asymptote for this specific function. Again, remember that the degree is the highest power of the polynomials in both the numerator and denominator. Let's proceed to case 3. If the degree of the numerator is greater than the degree of the denominator, then the graph has no horizontal asymptote. But we have to remember here, we have an exemption to this rule. Later, I will be presenting to you what is this exemption. Okay, so if the degree of the numerator is greater than the degree of the denominator, then the graph has no horizontal asymptote. Let's try this example. For example, you are given h of x equals x cubed minus 8 over x plus 2. So the degree of the numerator is 3 and the degree of the denominator is 1. So 3 is greater than 1. So therefore, this function, this rational function, has no horizontal asymptote. Okay. And now let's proceed to oblique asymptotes. How do we find the oblique asymptote? To find the oblique asymptote, we need to divide the numerator by the denominator using long division or synthetic division. The oblique asymptote is the resulting quotient disregarding the remainder. So this is now case number 4, which is the exemption in case number 3, which states that the degree of the numerator is greater than the degree of the denominator. This time, if the degree of the numerator is 1 higher than the degree of the denominator, then what we need to do is just simply divide the numerator by the denominator using long division or synthetic division. This time here, the degree of the numerator is 2, which is x squared plus 3x plus 4. And the degree of the denominator is 1. That is 1 here. So the denominator is x plus 2. So when we divide the numerator and the denominator, so when we divide x squared plus 3x plus 4 divided by the x plus 1, the quotient will be x plus 1 with a remainder 2. So for this example, our oblique asymptote is the line y equals x plus 1. So y equals x plus 1 is our oblique asymptote. If we are going to illustrate this one in the Cartesian plane, more or less we will have this graph here. So this is y equals x plus 1. Okay, that's it. Thank you and God bless.